Hello and welcome in my class. I am Professor Adesh Kumar Srivastav, Associate Professor, School of Management, BBD University, Lucknow. Today, I will be discussing about transmission media and their types. What is the transmission medium? The transmission medium can be defined as a pathway that can transmit information from a sender to a receiver. Transmission media are located below the physical layer and are controlled by the physical layer. Transmission media are also called communication channels. So basically, in common words, in common language, day-to-day working, we called it cables or wires. These are transmission media. Its other name is communication channel also. The type of transmission medium chosen for a network is related to the network's topology, protocol, and size. Understanding the characteristics of different types of transmission medium and how they relate to other aspects of a network is necessary for the development of a successful network. The following section discusses the types of transmission medium used in network. So what are the types of transmission medium? We'll discuss it ahead. If we bifurcate the transmission media, we can broadly classify the transmission media in two types, that is unguided transmission medium and guided transmission medium. The following chart categorizes the transmission media in detail. As we have broadly classified it into two, that is guided media and unguided media. If we talk about guided media, there are further classification, that is twisted pair cable, coaxial cable, power lines and fiber optic cable. So these are the further classification in guided medium, whereas in unguided medium there is radio transmission, microwave transmission, infrared transmission and light transmission. So now we'll discuss all these categories and their subcategories in detail. First of all, we'll discuss guided transmission medium. Guided transmission media are also called bounded media or wired media. They comprise cables or wires through which data is transferred. They are called guided since they provide a physical connect from the sender device to the receiver device. The signal traveling through these media are bounded by the physical limits of the medium. The most popular guided media are twisted pair cable, coaxial cable, power lines, and fiber optics. Now we will first discuss twisted pair cable. A twisted pair cable is made of two plastic insulated copper wires twisted together to form a single media, as you might be seeing in the picture. Out of these two wires, only one carries actual signal and another is used for ground reference. The twist between wires are helpful in reducing noise, that is electromagnetic interference and crosstalk. These are two types of twisted pair cable, that is shielded twisted pair cable and unshielded twisted pair cable. As you are seeing in the picture, this is shielded pair cable because there is a shield apart from the insulation, that is you are seeing the outer white covering, that is called shielded twisted pair cable. Shielded twisted pair cable, also known as STP. STP cables come with twisted wire pair connected in metal foil. This makes it more indifferent to noise and crosstalk. An unshielded twisted pair has 7 categories, each suitable for specific use. In computer network, Cat5, Cat5e and Cat6 cables are mostly used, as you are seeing all these three in your picture. UTP, that is untwisted pair cable, are connected by RJ45 connectors. Now we'll talk about coaxial cable. Coaxial cable has two wires of copper. The core wire lines in the center and it is made of solid conductor. The core is enclosed in an insulating sheet. The second wire is wrapped around over the sheet and that too in turn encased by insulator sheet. This all is covered by plastic cover, that is outside insulation. Because of its structure, the coax cable is capable of carrying high frequency signals than that of twisted pair cable. The wrapped structure provides it a good shield against noise and crosstalk. As you are seeing in the picture, there is a copper wire in between, that's a solid conductor. Thereafter, there is a plastic insulation, and after that, you are seeing the copper mesh, and after the copper mesh, you are seeing the outside insulation of coaxial cable. So, this is the entire structure of an coaxial cable. Coaxial cable provides high bandwidth rates of up to 450 Mbps. There are three categories of coax cables, names RG59, that is cable TV, it is used in cable TV, RG58 which is used in thin Ethernet, and RG11 that is used in thick Ethernet. So RG stands for radio government. Cables are connected using BNC connector and BNC T. BNC terminator is used to terminate the wire at the far ends. These all kinds of coaxial cables are shown in the picture so that you can easily understand that what type of the cables they are. There is a little difference in all the kinds of coaxial cables. Now we'll discuss about power lines. Power line communication, that is called PLC, is layer 1 physical layer technology which uses power cable to transmit data signals. In PLC, modulated data is sent over the cable. The receiver on the other end demodulates and interprets the data. The receiver end interprets the data sent by modulation technique. Because power lines are widely deployed, PLC can make all power devices controlled and monitored. PLC works in half duplex mode. There are two types of PLC, that is narrowband PLC and broadband PLC. Narrowband PLC provides lower data rates up to hundreds of kbps as they work at lower frequencies, 3 to 5000 kilohertz. They can be spread over several kilometers. Broadband PLC provides higher data rates up to 100 of Mbps, hundreds of Mbps and works at higher frequencies, that is 1.8 to 250 megahertz. They can not be as much extended as narrowband PLCs. Now we'll discuss another type of guided media, that is fiber optics. Fiber optic works on the properties of light. When light ray hits at critical angle, it tends to refract at 90 degree. This property has been used in fiber optics. The core of fiber optic cable is made of high quality glass or plastic. From one end of it, light is emitted, it travels through it, and at the other end, light detector detects light stream and convert it to electric data. Fiber optic provides the highest mode of speed. It comes in two modes. One is single mode fiber optic and second is multi-mode fiber. Single mode fiber can carry a single ray of light, whereas multimode is capable of carrying multiple beams of light. Fiber optic also comes in unidirectional and bidirectional capabilities. To connect and access fiber optic, special type of connectors are used. These can be subscriber channel, that is SC, is straight tip, that is ST, or MT RJ. Now we'll talk about unguided transmission medium. Unguided transmission media are also called wireless media. They transport data in the form of electromagnetic waves that do not require any cables for transmission. These media are bounded by geographical boundaries. This type of communication is commonly referred to as a wireless communication. Unguided signals can travel in three ways: ground propagation, sky propagation, and line of sight propagation. So, we'll understand all kinds of unguided transmission media in detail. Wireless signals are spread over in the air and are received and interpreted by appropriate antennas, where an antenna is attached to electrical circuit of a computer or wireless device. It converts the digital data into wireless signals and is spread all over within its frequency range. The receptor on the other end receives the signal and converts them back to digital data. This is how a transmission is possible in wireless signals, in wireless transmission medium. A little part of electromagnetic spectrum can be used for wireless transmission. You are seeing the rays, first is radio waves, then microwaves, then infrared, then ultraviolet, then X-rays and gamma rays. Whereas the microwaves and infrared are the visible light. We can use only radio waves, microwaves and infrared. So these are the little part of electromagnetic spectrum that can be used for wireless transmission. So now we'll understand the parts of commonly used unguided mediums. These are radio transmission, microwave transmission, infrared transmission and light transmission. First, we'll understand radio transmission. Radio frequency is easier to generate, and because of its large wavelength, it can penetrate through walls and structure alike. Radio wave can have wavelength from 1 mm to 1 lakh kilometer and have frequency ranging from 3 Hz, extremely low frequency, to 300 gigahertz, that is extremely high frequency. So radio frequencies are subdivided into 6 bands. Radio waves at lower frequency can travel through walls, whereas higher radio frequency can travel in a straight line and bounce back. The power of low frequency wave decreases sharply as they cover long distances. High frequency radio wave have more power. Lower frequencies such as VLF, LF and MF bands can travel on the ground up to 1000 kilometers over the Earth's surface. Radio waves of high frequencies are prone to be absorbed by rain and other obstacles and other climatic conditions. They use ionosphere of Earth atmosphere. High frequency radio waves such as HF and VHF bands are spread upwards. When they reach ionosphere, they are refracted back to the Earth. Now we'll understand microwave transmission. Electromagnetic waves above 100 MHz tend to travel in a straight line, and signals over them can be sent by beaming those waves towards one particular station. Because microwave travels in straight lines, both sender and receiver must be aligned to be strictly in line of sight communication. Microwave can have wavelength ranging from 1 mm to 1 meter and frequency ranging from 300 MHz to 300 GHz. Microwave antennas concentrate the wave, making a beam of it. As shown in the picture above, multiple antennas can be aligned to reach further. Microwaves have higher frequencies and do not penetrate wall like obstacles. Microwave transmission depends highly upon the weather conditions and frequency it is using. Now, we will discuss infrared transmission. We are very much familiar with infrared transmission. You must be using remotes of various devices at your home, that is television sets and ACs and many more. So the remote is working on infrared pattern and technology. Infrared wave lies in between visible light spectrum and microwaves. It has wavelength of 700 nanometer to 1 mm, and that is millimeter, and frequency ranges from 300 gigahertz to 430 gigahertz. Infrared wave is used for very short range communication purposes such as television and its remote. The very popular use of infrared in today's world. Infrared travels in a straight line, hence it is directional by nature. Because of high frequency range, infrared cannot cross wall like obstacles. Now we will discuss light transmission. Highest most electromagnetic spectrum which can be used for data transmission is light or optical signaling. This is achieved by means of laser light. Because of frequency light uses, it tends to travel strictly in a straight line. Hence, the sender and receiver must be in the line of sight communication. Because laser transmission is unidirectional at both ends of communication, the laser and the photo detector needs to be installed. Laser beam is generally 1 mm wide, hence it is work of precision to align two far receptors, each pointing to laser source. As you are seeing in a picture, that is line of sight communication is made. Laser works as TX transmitter and photodetector works at RX, that is receiver. Laser cannot penetrate obstacles such as walls, rain and thick fog. Additionally, beam is distorted by wind, atmosphere temperature or variations in temperature in the path. So laser is safe for data transmission as it is very difficult to tap 1 mm wide laser without interrupting the communication channel. So thank you all for watching this video. If you have any questions, any doubts, any queries, you can find me at adsri6 at gmail.com, or you can email me or message me through this and through my WhatsApp and this channel, YouTube channel. You all can reach to me anytime, offline and online. Thank you for watching this video. Thanks a lot.